We have another complex function here, basically a linear form. We have here limit of our function 3z minus 2 as z approaches 2 plus 1. Take note that we can, of course, implement substitution in solving for the limit or evaluating the limit of the given complex function as the value of z, which is it approaching to 2 plus I. But this time, let me, of course, show the application of the limit theorem previously discussed. It's up to you which you will follow, but of course, I guarantee that you will get the same result as long as you are too cautious with your steps. Let's start here with the limit of 3z minus 2 as z is approaching to 2 plus I. Notice that our z sub 0 is, of course, a complex number expressed as 2 plus I. So what we could do here, allow me to use first the limit theorem. Of course, we have the limit theorem for the difference. You have here a difference of this, right? Two terms. You have here the limit of your 3z as z approaches 2 plus I. And you have here minus the limit of 2 as z approaches 2 plus I. Hey, again, there's nothing wrong with substitution, but allow me to show this first before providing you the process of direct substitution, because we cannot guarantee that all the time f of whatever z sub 0 will be equivalent to the limit, because there might be some instances where our given complex function is expressed in either a piecewise function or other functions where the limit from the left and the right would not be equal, or even one of them will not exist. So for this, take note, we have here the constant. We have the limit theorem for constants. You have 3 times the limit of your z as z approaches to 2 plus I minus the limit of 2 as z approaches 2 plus I. Again, pardon me of showing here the step-by-step process, because not all of us could actually get the direct process immediately. So allow me to show this as one alternative. We know this to be 3. And we have here our z as this is the value. So we have here 2 plus I minus the limit of the constant is the constant itself, true for both functions involving real numbers and complex function. So basically this is just equal to 6 plus 3i minus 2, which can be combined into 4. That's 6 minus 2 plus 3i. We combine the real part of the values here. So this is the limit of our 3z minus 2 as z approaches 2 plus I. Now, this is by the use of limit theorems. Allow me here to use the other method, as mentioned, the direct substitution. So you have here the limit of your 3z minus 2, sorry for that, again, minus 2 as z approaches 2 plus I. By means of direct substitution, whatever the value of this, automatically substituting there. So you will get here 3 times 2 plus I, sorry for that, again, 2 plus I minus 2, which is similar to this form here. So just one step, you're able to guarantee this value now, even without using the limit theorems. But of course, this is, again, to be what do you call this one, to be examined thoroughly. This is 3 times 2, 6 plus 3i minus 2, which will give you the same value of 4 plus 3i. Now, it's up to you if you would like to use direct substitution. You may, definitely, yes. Or, if you're asked to show the result using the limit theorems, you may copy this and you will still get the same result. Thank you very much for watching.